to Hanstholm here in northwest Denmark. What you see behind me is WaveStar, which is a wave energy device. It works by operating paddles, and it may be one of the first devices that can also operate with wind turbines far out at sea. Now, some of the big issues for something this size, and it is the size of a little oil rig, are all to do with scale and cost, and how you get something from the laboratory, from the computer screen, into a test tank, into a small harbour, and then into this kind of position where it's almost ready to go. That takes years, and it takes patience, and it takes a lot of patience from investors as well, and understanding. And that's all got this device so far. Let's find out how it's going to get right out to sea. And this is where the dream began, in a wave tank at Aalborg University for 1 year of patient repetitive testing. The wave tank's not glamorous, but it is vital. Wave devices must be strong enough to survive storms, but cheap enough to produce affordable energy. That's why WaveStar Junior began life as a 40th scale model, before scaling up and popping out here, in Nissum-Bredning Harbour, in stormy North Jutland, for a year of the real thing. This 1/10th scale device survived several storms without damage. So finally, 6 years after its first patent, the final changes were made to produce WaveStar Senior. But even this whopper is still just a half-scale device. Jens Peter Kofod from Aalborg University has been involved with WaveStar from its early tank testing days.
The full-scale device will have floaters the size of a house, basically, where this is more or less the size of a shed or a garage, so a 5-diameter floater. And on this one, we got 2 floaters on the structure. In principle, it could accommodate up to 6. On this structure, but this is primarily for testing out the capabilities of the device. And the purpose of this installation is as much to produce data as it is to actually produce power.
But either you must be very patient people, or your investors must be very patient people.
Yes.
Because here is this piece of kit, and people would think, why don't you get on and generate energy?
Yeah, I can assure you that there is work being done around the clock to achieve that. But it's not a very straightforward business, you could say. So there's a lot of...
What would be the danger of rushing into trying to produce energy because your investors want to see something happening? Why do you have to take it slow like this?
Well, it's all a matter of ensuring that you don't damage your kit and operate it within your safety margins.
Even in force 5 winds, WaveStar is rock steady, but our recording equipment isn't. So we have to come back on shore to keep talking. Jens Peter tells me these conditions are nothing compared to the winter storms, but that's what proper testing is all about.
In a full-scale version of the device behind us, there will be 20 floaters on one machine. And each of those floaters will then have a diameter of 10 meters, so like the size of a house, basically.
So it will minimize the amount of hardware that you have to maintain that has to be hit by the waves out there.
Yes. Here you're concentrating, you can say, a number of what we call point absorbers, so individual small elements of a machine onto one main structure. And from a maintenance point of view, that is a nice feature because you can visit this one machine. You don't have to go to the individual smaller machines. And then this machine has the philosophy for survivability, to be able to lift itself and the floaters out of the water. That's
with the legs which have those holes in it,
yes,
which allow it to be jacked up in
yes,
very bad weather.
Yes, and that's basically just to minimize the loadings on the structure, because we want to have access to the power in the waves in the everyday conditions, but the power in the waves in extreme conditions, so in very bad stormy weather, is maybe 30, 50, 100 times bigger than the forces that you'll have in a day like this.
So tell me this, people will think that's impressive, but do you know something? Oil rigs have already done it.
Yes.
Why can't we learn from oil rigs and just use their technology for this?
Well, we can learn from it. There's a lot of experience there that we are, you can say, building on. But for oil rigs, which are pumping carbon up of the ground, the amount of power that is produced per day is enormous compared to what comes out of a wave energy installation like this.
So that means that's why they have such very high levels of investment. You would love that.
Yes, certainly. But the good thing here is that we can, once it's there, it can go on forever.
You think?
Yeah, well, maybe not that specific machine, but the resource will be there forever. And we cannot keep on pumping oil up of the ground.
And when we get to money again, how much did the Wavestar behind us cost?
In order of magnitude, something like 10 million pounds or so for the installation that's here.
So you can't afford to make mistakes with that?
No, that's why you can say for each step that you go, the investment increases enormously. So you need to get as much information out of the smaller scale as possible. But of course there are things that you cannot test out in the small scale. And for that reason you need to go progressively to larger and larger installations.
And that's also why it's taking so long for marine energy to come on stream, isn't it?
Yes, and especially when you get to this size of machinery, it takes time because it's big equipment and it means big money, and it's not so easy to raise always.
And we're standing beside another breakwater where there's actually the remnants of a device that went wrong.
Yes, and that's maybe an example of what happens if you try to cut corners and maybe not do all of the exercises that you can do in laboratory scale before moving on and investing in a big machinery. So
just to finish, get us excited about the potential of what's behind us. What could it deliver compared, let's say, to wind turbines?
If we talk about a full-scale installation, so where the individual floaters are double the size of what we have behind us, and 20 floaters on one installation, we're talking about an installed capacity which corresponds to 2-3 times the size of the current offshore wind turbines. And if we compare to the ones that we have here, it's maybe 10-20 times or so, because these are old turbines, so considerably smaller than what is put out to sea today.
The potential is huge, and the number of changes to Wavestar's design is likely to be large as well. Each change needs more testing, and that brings delay. But, like a pint of a certain Irish beer, you can't rush the development of a successful wave device. Laurent Marquis, you're technical director of Wavestar. Now, tell us first of all, this didn't start off necessarily as a star idea, did it? It was going to be called something different because it looked like something different.
Oh, at the beginning, that's right. When we built the first prototype in Aalborg University, it was called the 1,000 legs because it was a small legs around the machine moving up and down, and it looks like a 1,000 legs animal. So that was the beginning. And stars, it's come also from the point that we want to build more equipment together, that it make a star in the water. That was the point. So
things change in development phenomenally, don't they?
Yes, it does. Each time you pass through something, you have to change again and think again all the things you have done. When we make the first prototype at Aalborg, we find out some new thing we want to improve in the next prototype we build in Nissum-Branning, and it was a start for this machine. And when we build that machine, we find out also a lot of improvement we want to do on the machine. So every time things are improving, of course, yes.
Now we see actually today the paddles are moving. What can you tell us about what we're seeing there with the paddles? How is that creating energy?
Oh, it's quite simple. The wave is coming through the machine, and then we have this float which is made in glass fiber, and it's going up and down, moving of the wave movement. And on this arm, you can see the steel arm you have where the float is. There is an hydraulic cylinder, and the oil is coming up and down in the hydraulic cylinder, going through a pump and activating a generator in that way. So it's a way we are generating energy from the wave.
Are all the electronics above the water? Because that must be a big issue to keep them dry.
That's right. That's one of the advantages of the equipment, as you see. There is nothing in the water, only the floats and the forelegs where the machine is based on. All the electronic, all the hydraulic, all the motors, they are inside the tube. And the tube is completely protected with a hydro system working around the tube and keep it clean and dry.
It's right in its shore at the moment, and it had a very frisky winter, so you know it can survive high winds, but it can survive high winds sitting on the edge of that pier. That's not where it's destined, is it? The big final production, it's destined for offshore.
Yes, it is, of course. Why it is at this pier? It's because it's a test equipment, and we wanted to see if it was possible to take energy out from the wave. The other thing it was, as you say, to see if it can stay during the winter, during the stormy weather also. And I can assure you, in Hanstholm we have a lot of storm. We are measuring the wave, and when we can see that there is a storm which is preparing, we are taking the floats up, as you can see on the red one. The other one will move up, and then we move the machine completely up. So the storm will pass through the machine without making any damage on the machine. That's the point.
And will you be able to make those changes remotely?
Yes, completely. Actually, we have our engineers in Copenhagen working on the machine, so everything is controlled by internet. That's the way to do things today. So we have people already today on the machine, but it's only to make tests on the machine because it's a test section. But in the future, the machine is completely controlled by computer far away from the machine.
Okay, the future. This is expensive. I understand it's about £10 million worth of kit we're looking at, yes. And that's not even the final one yet. How can you manage to keep costs down, and how can you deploy it to save money?
That's a big point, of course. This is a prototype, so a prototype is always costly. There is no doubt about this. So there is a big focus to decrease the price. The other thing it is to improve the efficiency of the machine. I can tell you that this machine has cost, as you say, £10 million, something like that. On the next one, we have already set the price down with 50% already, just to look at the construction, make it more clever, and again, we learn every time we make a new construction. We are more and more clever at every time.
Will a big way to save money be to site it with offshore wind turbines?
Of course, there is a great advantage to be together with other equipment which use the same common equipment. So offshore could be a very good alternative to be with offshore mills. We will use the same infrastructure, the maintenance people, and everything which can be. It's another way also to regulate the output, because the wave and the wind are not working always at the same time. So it could be a good advantage to have the two technologies together, that we can have a more smoothly output of the system. You have a distance of something like 300 to 400 meters between each windmill, so there is a place enough for our machine. If you have a floating equipment, it will be a big problem to have that between the machine. But with our equipment, that's not an issue. It will be nice.
Equimar is an EU-funded project producing industry standards to make marine energy work.